Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over an example on the application of derivatives. Um, we're going to be looking at related rates with special focus on cones. All right, let's take a look at the problem. It reads, a conical pit is being filled with concrete. The pit has a base radius of 10 centimeters and a depth of 30 centimeters. The pit is being filled so that the height of water rises at 2 centimeters per second. Find the following in terms of V and H, including meaning and units. So we are to find the HDT and the VDT, and part C, how fast is the pit being filled at the point in time the water level is 4 centimeters. All right? Okay, so the first thing we want to do, let's give ourselves a sketch of the situation. All right, so let's assume that that's the conical pit right here. So we know that the base radius is 10, so this right here is 10, and the height of the conical pit is 30 centimeters. Okay, that's the height or the depth, depending on where you're looking at it from. So this entire um, length right here is 30 centimeters. Okay, all right, so let's just call this portion right here, let's call this H, and let's call this R. What we have set up here is a pair of similar triangles. All right. Now, what is the formula that relates the volume of the cone with R and H? The formula is V equals 1/3 pi R squared times the height. Now we have to find the HDT and the VDT in terms of just V and H. So we need to substitute R with H. Okay, so what is the relationship between the height and the radius of a cone that is that has a depth of 30 centimeters and a base radius of 10 centimeters? In order to do this, we have to use our knowledge of similar triangles from geometry. So we have these two similar triangles here. So looking at the entire pit, the base radius is 10. So 10, the base radius over the height of 30. So that's the big triangle. We have a big triangle there. And then a little small triangle, let me put that in blue. So the little triangle is in blue, as you can see right there. For the little triangle, the dimension that corresponds with the radius of the main cone is the radius of the base of the little triangle. Okay, so this side right here is R, goes on top, and we have that R over the height. Okay, because this height corresponds to the height of the cone. We know that from geometry, if you have two similar triangles, corresponding sides are in proportion. Okay? Now, our goal is to express R in terms of H. So all we're going to do with this ratio is isolate R and substitute its value for R here. Okay, so to accomplish that, we can divide both sides by 10 and then multiply both sides by H. So what we'll have is R is equal to H over 3. Okay, now let's go back to the volume. We're going to substitute H over 3 for R here. So our volume V is equal to 1/3 pi. Instead of r, we have h over 3 square times h. Let's go ahead and simplify that. We have the volume V equals, in the numerator, we have pi h to the third, h squared times h, over 3 times 3 squared, which is 9, so it's 27. All right, so the volume is pi times the cube of the height divided by 27. Now let's proceed to find the h dt and the v dt, okay? Let's start with the h dt first. We're going to differentiate this with respect to time. Derivative of v to the first power is 1 using the chain rule, dv dt. And then here we can factor out pi over 27. Derivative of h to the third power with respect to time using the power rule is 3h squared dh dt. Okay, so dv dt, which is one of our answers, is, we can see this 3 here goes here once, and 3 goes here 9 times. So we can write this as pi h squared over 9. Let's write that 9 again. Pi h squared over 9 dh dt. Okay, so that's dv dt. The problem asked us to find the h dt. So to accomplish that, we will simply divide both sides by pi h squared over 9, or simply multiply by the reciprocal of that coefficient, which is 9 over pi h squared. Both sides. And then the h dt, this cancels out with that. Okay. The h dt is going to become 9 over pi h squared dv dt. Okay, so that's the h dt. We also need to find dv dt, but we already know what dv dt is. So for the b part, dv dt is equal to this piece right here, pi h squared over 9 dh dt. Okay? All right, so what do these functions mean? Let's start with the a part. What is the h dt? The h dt is the rate at which the height is changing. Okay, rate at which the height is changing as that pit is getting filled. Okay, it's changing. And then what's the unit for the h dt? Height is centimeters, t is in seconds, so the unit is going to be centimeters per second. Now, what is the meaning of dv dt? That is the rate at which the volume is changing. The rate at which the volume is changing. That's the meaning of dh dt, okay? And what's the unit here? You know, the unit is the dimension of volume is length cubed. So the length here is centimeters. So we have centimeter cubed, and the time measure is seconds. So centimeters cubed per second. All right, so for the C part, we're to determine how fast the pit is being filled at the point in time that the water level is 4 centimeters. Okay, so the rate at which the pit is being filled, the keyword here is filled, is dv dt, change in volume, when the water level, this is the height, is equal to 4. Okay, so remember, we already know what the rate at which the water level rises is. So water rises at 2 centimeters. So this one is the HDT. Okay, so we're just going to plug in the HDT, H, and H into our dVdt formula, and then use that to find dVdt. Okay, so let's go ahead and write that down. For this example, we have, this is the C part. We know that dVdt, the change in volume, is equal to pi h squared over 9 pi h squared over 9 the HDT. And then from what we just did, we know that h, the height, is equal to, what's the height again? 4 centimeters for the height. H is 4. And then the HDT, the rate at which water is getting poured into the rate at which the water level is changing is 2 centimeters per second. So it's the HDT is 2 centimeters per second. Let's go ahead and write that down. The HDT is 2 centimeters per second, and then H is 4 centimeters. So now we can plug in these two values into this equation and solve for dV dt. Okay, let's go ahead and do that. dV dt equals pi over 9 times 4 squared. The HDT is 2. Okay, so this becomes 4 times 4 is 16 times 2 is 32. We have 32 pi over 9. And the unit is centimeter cubed per second. This is volume per time, okay? So what does this answer mean? This answer means that the rate at which the pit is being filled when the height uh, is 4 centimeters. What's the rate at which it's being filled is 32 pi over 9 centimeter cube per second. Okay, so there you have it. Thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. If you have any questions or comments, feel free to include it in the comments section below this video. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day.